Okay, I wanted to do the basics of statistics and informatics. We're going to start with our 2x2 table over here. So disease positive, disease negative, test positive, test negative. If they're both true, it's a true positive. If they're both negative, it's a true negative. If there's no disease and the test is positive, it'll be a false positive. If there is a disease and the test is negative, it'll be a false negative. First thing that we want to talk about is prevalence. Prevalence is how many people have the disease. So true positive plus false negative is the people that have the disease. So this is going to be how many people have the disease, and it's going to be equal to true positive plus false negative. In probability terms, it's how many people have the disease. Sensitivity. So when we talk about sensitivity, so usually what I like to do is I actually start with the end. This is my own little trick. I put a false of whatever it is, and then I put the opposites on the bottom and on the top, and I add them. So true positive over true positive plus false negative. Obviously, true positive plus false negative is how many people have the disease. So that's disease positive. This is true positive. In probability speak, it's going to be the probability of having the test positive for those who have the disease. The other way to think about it is just start from here, right? So it's of those who have the disease over here, how many of them are actually going to test positive? Specificity, so it has a P, so I start from the opposite way. I do my false positive, I align the numbers over here, I throw in the opposite on the top and the bottom with an addition. True negative plus false positive is my disease negative, meaning the people that do not have the disease. So the other way of thinking about it is those who are negative of those who don't have the disease appropriately. So of the people that do not have the disease, how many of them are testing negative? Because sensitivity has this true positive on the top, it is also known as the true positive rate, because it's those who actually test positive of those who have the disease. Sensitivity, because it has a true negative on top, is also known as the true negative rate, because it's those who test negative from those that don't have the disease. Fallout is the same thing as saying false positive rate. Easy to remember, fall sounds like false, and it's the people who fall out, meaning how many of those people that do not have the disease, so disease negative, are testing positive inappropriately, false positive. In other words, this will be how many people are falsely positive over the people who are false positive plus true negative. Let's just fix that. So this is going to be how many people are testing positive of those who do not have the disease. Moving on to accuracy. Accuracy is how many people are testing appropriately. So that'll be true positive plus true negative over the total. So if we're going to break it out, it's going to be true positive plus true negative over true positive plus true negative plus false negative plus false positive. And it'll be basically how often are you right, this true positive plus true negative, over your total. Moving on to your positive predictive value. Positive predictive value, rather than looking down diseases, looks across the test. And so your positive predictive value, positive, so you think about positive. So it's your total positive, right? That's going to be in your numerator. And then you're looking across the test. So for your positive, it's across a positive test. Across a positive test, which will be your true positive plus false positive. And in probability speak, it's going to be your positive test among all of those who, let's do that again. It's going to be how many of those actually have the disease among those who are testing positive, right? Because all of these guys are testing positive and this one will have the disease. Your negative predictive value is the same thing, but across the negative side. So it's your true negative over those who have a negative test. And so it's true negative over false negative plus true negative. And so it is your probability for those who have a negative test of those testing, among those who have a negative test, how many of those will actually not have the disease? So that's your negative predictive value. Of note, positive predictive value, negative predictive value, both of those are contingent on the prevalence, meaning that if the prevalence is higher, then your positive predictive value will be higher. If the prevalence is lower, then your negative predictive value will be higher, whereas sensitivity and specificity are not dependent on that. And so if you're trying to look for, if you don't know the prevalence, you are better off getting sensitivity and specificity. Okay, moving on to likelihood ratios. So likelihood ratios always have sensitivity on the top and specificity on the bottom. So let me write that out. Sensitivity and specificity. And then there's always a 1 minus somewhere. And so the question is, how do you remember where that 1 minus goes? So for positive likelihood ratio, it's going to be your true positive rate that's in the denominator. And so when you're thinking about your true positive rate, it's your false positive rate that's in the denominator. And so it is going to be your true positive rate in the numerator, so it's your sensitivity, which means that your false positive rate is the one that's going to have the 1 minus. Negative likelihood ratio is going to be the opposite, so it's going to be 1 minus sensitivity over specificity. Okay, and so if you're actually going to write it out, you can just write it out based on these terms. So your sensitivity is going to be true positive over true positive plus false negative, true positive plus false negative, over 1 minus specificity is your true negative over true negative plus false positive. And then your negative likelihood ratio is going to be 1 minus your sensitivity. So it's going to be true positive over true positive plus false negative in the numerator. And then your denominator is going to be your specificity, which is your true negative plus false positive in the denominator. So we have that written out. And that completes, let's just put this in parentheses. So that completes your terms. One more thing, so your negative likelihood ratio is going to be your false negative rate over your true negative rate, right? And so your true negative rate is the same thing as your specificity, so those line up. And the reason is because when you think about negative likelihood ratio, it means if you have a pretest odds, how much does it lower your pretest odds? So it's going to be a fraction. And the smaller the fraction, the more that it makes it, that whatever the test comes out, it's going to make it less likely that you have the diagnosis. So you want that true negative rate to be in the denominator when you're thinking about it, as opposed to positive likelihood ratio, where you want that true positive rate to be in the numerator, because the higher the number, the more it increases the odds of you having that diagnosis. This is the basics of informatics statistics.